Happy day. I am Dr. Sunitha Rani from the Department of Computer Science and Information Technology. I welcome you all to this module on Quine McCluskey's method. Quine McCluskey's method is a very simple method to simplify the Boolean functions. This method is also termed as the tabulation method. Now we shall see the simplification of Boolean functions. Boolean functions can be simplified using the Boolean algebra rules as well as the Karnaugh map, the K-map, which is abbreviated as the K-map. The K-map works great with variables up to 5, but when it is more than 5, the visual grouping becomes very difficult with more number of cells. Hence, we move on to a method called as the tabulation method. This tabulation method is ideal for handling complex Boolean expressions. It provides a structured approach to simplification. So, now the simplification process for Quine McCluskey method is a two-step process. In the first step, we will see how to identify the prime implicants, and the next step is to select the minimum cover. When we come to this prime implicants, we have to determine the essential terms for simplification, and also we have to select these terms which will be the prime implicants. From the list of prime implicants, we have to select the terms with least number of literals, and this ensures we get a minimal Boolean expression. So, this is just a two-step procedure. In the first step, as I told you, we have to identify the prime implicants. Now, we shall see how to identify the prime implicants. It is a step-by-step process. First, start with the given Boolean function. So, given Boolean function, you will have minterms in the Boolean function. List out all the minterms and their corresponding binary equivalents. So, make a list of it. Once that list is made, we have to group the minterms according to the number of ones present in the binary equivalent. So, when we group them, we start with group 0, that is there are no ones in that group, and then we move on to group 1 where you will have 1 1, and move on to group 2 where you have 2 ones, and so on. Likewise, we do the grouping process. Then you have to compare the minterms from the adjacent groups. When I say adjacent groups, there is one constraint on this. You can compare the adjacent groups only if they differ by one variable. So, that condition is very important. So, when they differ by one variable, you can compare them, and when you compare them, you combine to form a term with one less literal. So, this process is repeated until there are no further eliminations are possible. Finally, we identify the prime implicants by combining the remaining unmarked terms as well as the previously combined but unmarked terms. So, this is how we get our prime implicants. Let us just see this with the help of an example. So, the example says we have to simplify the given function by Quine McCluskey method. So, f of a, b, c, d equal to summation 0, 5, 7, 8, 13 and 15. So, now we shall see as a step-by-step procedure how to solve this using the tabulation method. Right. So, coming to the solution. First, we have to list out all the minterms and their equivalent binary. So, this is how it is listed with minterms 0, 5, 7, 8, 13, 15, and the corresponding binary are placed there. That is, for 0, we have to have the binary equivalent in 4 digits. Corresponding to 5, we have 0, 1, 0, 1, and 7, it is 0, 1, 1, and so on. So this is how you list out all the minterms with the binary equivalents. After listing out the binary equivalents, we have to group them according to the number of ones. But to go to grouping, you first list out the number of ones in each binary equivalent. In the first row, you don't have any ones, it is a 0 ones, and here you have a 1 1, and next you have 2 ones, then 3 ones, followed by again 3 ones and 4 ones. So what we do is, we go to the method of grouping, we assign group names, that is G0, G1, G2, G3, etc. And here if you see, next to 7 and 13 both have G3. So the reason is, we are going to combine these two and form one group. And this is how we place them once you combine them. It is going to be 0, 8, 5, 7, 13, 15, whereas 7 and 13 are grouped together because both of them have 3 ones in their binary equivalent. So again, we have to remember that there is a constraint. You can take one group and compare it with the adjacent group only if they differ by one variable. So we take the first row wherein you have 4 zeros, and in the second row you have 3 zeros and 1 1, which means it differs only by one variable, 0 and 1. So you can consider this for comparison. When you consider this for comparison, you place it in the next column where you write it as 0, 8, and you write all the 3 zeros which are same in both the groups, and the one variable which differs is 0 and 1. In that position you place a dash. Then coming to the next one. So as you have compared these two, we move on to the next group. So here in the next group you have 5 and 7 13, because 7 13 forms a single group. So we will be comparing 5 with 7 and 5 with 13. So here when you take 5 and 7 differ by only one bit. So that bit position is marked with a dash. In column B, we write it as 5, 7, and we write the 0, 1, hyphen 1. Then you compare 5 with 13. So it differs again only by one bit. So it is 5, 13, which is nothing but dash 1, 0, 1. Whichever position it differs by one variable, we place a dash and write the remaining digits as they are. Now coming to that last group, we have to compare the previous group and the last group. When you are doing it, it is going to be 7, 15, wherein it differs only by one bit, and that bit position is placed with a dash. So you get 7, 15 dash 1, 1, 1. Then compare 13 with 15. When you compare 13 with 15, you get 1, 1 dash 1. Now we are ready with column B, and as we saw the procedure, it has to be continued until no more simplification is possible. Now we move on to column B. In column B, you consider the first one as group 1, group 2, group 3. Take the digits in group 1 and try comparing it with the digits in group 2 of 5, 7. This is not possible because you have more than one digit which differs. So try comparing it with 5 and 13. Again that is not possible because it differs by more than one bit. So we move on to the group 2 and group 3. Take 5, 7. The corresponding digits are 0, 1 dash 1, and try comparing it with 7, 15. It differs by more than one bit. So that is not possible, and also you should remember that the dash should be in the same position when you are comparing. So that is the reason why we are going to take 5, 7 and compare it with 13, 15. So when you compare it with 13, 15, the dash is in the same position and it differs only by one bit, that is 0 and 1. The rest of the digits are same. So you write it as 5, 7, 13, 15, and wherever it differs, you replace it with the dash. So it becomes as dash 1 dash 1. Now come to 5, 13. 5, 13 when compared with 7, 15, you get it as dash 1 dash 1 because the dash is in the same position and also it differs only by 1 bit. But whereas when you take 5, 13 and compare it with 13, 15, it is not possible because you have more than 1 bit which differs. So you get a column C which has 5, 7, 13, 15 and 5, 13, 7, 15. Once you do this, you are going to select the unchecked terms. So first we have to see which are the checked terms. Those groups which you had selected for comparison and which you were able to do the comparison, you check them. So in column A, we had compared all the groups with their adjacent groups in one way or the other. So you have a check mark next to them. Then coming to column B, we were not able to do the comparison with the first group. So that is unchecked and all others are checked. And in the last group, we just have dash 1 dash 1 and even for 5, 13, 7, 15, you have dash 1 dash 1. So now it is the selecting of prime implicants. You have to use 08 which corresponds to dash 0, 0, 0 and you select dash 1 dash 1. It is a duplicate, it is enough if you select it once. So this is how you have to select the unchecked terms. To sum up, you have the first term in column B is unchecked and similarly the two terms in column C are unchecked. So from column C, it is enough if you just choose one because the other is the duplicate of the previous one. The unchecked terms are dash 0, 0, 0 which corresponds to B dash, C dash and D dash and the next term is dash 1 dash 1 which corresponds to B and D. So after finding them, you have to just combine to write your final solution. The final solution is F equal to B, D plus B dash, C dash and D dash. Thank you. If you had found this interesting, like, share and subscribe to M.O.P. Classroom.